Let me just, since there are like 5 people in here, are you guys Windows admins today, or so you're not? You're a Unix guy. Okay. Just a DBA. You just came in the corner.
I'm a DBA. My company is partially being forced to deploy on Windows.
Okay. Yeah.
Now I'm a developer guy.
Right. Well, that'll work. That'll work. So the talk is deploying Postgres in a Windows enterprise. So I'm going to start with looking at what's actually, for the purpose of this talk, a Windows enterprise. We're going to go through installations, and the main part of the talk will be focused against integration and access to Active Directory data. And I'm going to make a couple of quick notes about how you will use Windows tools for monitoring. So what actually is a Windows enterprise? I'm going to start with a couple of, you see I'm really a graphical artist here, right? I found some icons. This is not what I would consider a Windows enterprise. Just a couple of servers, a couple of clients. This is like a workgroup style or small company. In these scenarios, it's really simple, really to deploy whatever you want. This is also not what I consider a Windows enterprise. It's a nice, you may have as many servers as you want, and then you have like this big web farm, and all your clients are across the internet running their browser. It may be enterprise size, and you may be running Windows on your servers, but at least for the purpose of this talk, that is not a Windows enterprise. Now we're starting to approach the Windows enterprise. The magic word here really being Active Directory. And you have a large number of Windows servers. More importantly, you have a large number of Windows clients. And these are fat clients, domain-style connections, and you have one or more Active Directory setups. It may be a single Active Directory. It may be one of those nice examples that Microsoft have, which spans about 12 continents and 4 planets and whatever. But you have Active Directory. Your clients are predominantly Windows. Very common today is that you have a lot of Linux servers in this enterprise. There aren't that many pure Windows enterprises out there anymore. I'd still consider this a Windows enterprise. You have your login systems based on Active Directory. You have your directory services that's coming from there. Most of your core networking services will be coming out of Windows machines. And you may have Linux-based firewalls or web servers or database servers or whatever. And this is the scenario that I'll be looking at here, really. If you're just doing a workgroup deployment, you don't need to go to tool to realize how that works. So first, the installation phase of Postgres. Postgres is simple to get out in your Windows environment. We have the MSI installer. It integrates with all your existing products. It's unlike some other MSI installers that are just like a binary blob to the system, it's an actual Windows installer. So if you have an enterprise deployment system to deploy software that integrates with an MS installer and manages to like change tables and stuff in it on the fly, it will work with our installer. It will automatically install all the dependencies that you need if you need extra Kerberos libraries, SSL libraries, the get text libraries. All these things are bundled, and you can just push it out there with whatever method you prefer. If you're installing the server, it will automatically create your service account, because we won't run as a local system. We'll consider it a security problem. It will set the permissions as necessary on all the files in the file system, even explicitly denying itself permission, so that if there were to be a security issue in it, has automatically denied itself permission to modify its own binary files. It will only have write permissions in its data directory. And it fully supports running a silent install. It can be completely silent. It can be what's called a basic mode user interface, where you just get a progress bar, nothing more. And it can be the restricted mode user interface, where you will get a progress bar and it will actually tell you which files it's copying. And of course, you can run it in the fully interactive mode. And you can use this to push out the server only, the server and client, or just the client. You'd normally not use any sort of silent automated install if you're pushing out your servers, unless you're like those guys who install 5,000 servers with it. They exist. It's kind of scary that they do, but they do. But if you're pushing out the client to your entire enterprise with 5,000 or 10,000 desktops, you'll want to do it silently. This will work pretty well for that. You can also get the binaries no installer package, which is just every XE and every DLL in a big zip file. and you can do whatever you want with it. If you're deploying it as a part of another product, wrap it in your own installer, anything you want there. It will require that you take care of all dependencies on your own. It's documented where you can get them, but it won't be handled automatically in that case. And in this case, we do support the Xcopy deployment, as Microsoft calls it these days. We don't write a lot of registry entries. Actually, the Postgres installer will write, I think, 3 registry entries identifying that it has installed Postgres for tools like pgadmin to know that it's there, but they are in no way required for running the server. ODBC requires registry entries. That's not our fault, that's ODBC's fault. There's nothing we can do about that. It won't create the account for you, it won't set the permissions. You'll have to do all that from your own installer. And this one you can use if you need a custom build of Postgres. Say if you want to build it without support for Kerberos and SSL in order to cut down the size of the package or the main dependencies to maintain. This would be the way to go. You can rewrap the MSI installer without these files and change it around, but that's going to be a lot of work. You normally won't want to do that if you can avoid it. But license-wise, you're free to do it. The installer is, of course, also BSD licensed. So moving on towards the main part that we will look at here, which is the Active Directory. Well, I'm sure you, since all the people here, you all know what Active Directory is, right? Good. So what we'll want with Active Directory in the enterprise is mainly, the first thing you'd want is integrated authentication. That's actually what Microsoft calls it. I don't know exactly what Oracle calls it, but they have it. The idea is you're logged into your machine, you're logged into the domain. Why should you log in yet again to access the database? This is normally only interesting when you have app clients on these machines. If you have a web app, you might want integrated access from the web client to the web server, but then the web server will be connecting to the database with just a single user or a couple of different row users with a fixed password. Using this integrated authentication is very, very common in the scenario where you have a SQL Server backend and an Access front end, and we want to migrate those. What a lot of people don't realize, at least in Postgres, you still have to create a database user. Just because you have an account in the domain does not mean that you have an account in the database. In some cases that can be a hassle, in a lot of cases that can be good because you don't want everyone to automatically get into your database, even if you random permissions in. But you need to create the database user, it has to have the same name in the database as it does in the directory. Whether this actually works is dependent on the client interface. Anything that's libpq or built on top of libpq will be able to support integrated authentication for Active Directory. The ODBC driver, that's the PSQL ODBC, supports this. The ODBC driver from command prompt, ODBC-ng, does not support this because it's not built on top of libpq. And they also haven't sort of specifically implemented it. So if you're using ODBC, you will need to use the original ODBC version. The JDBC currently does not support this. Work is being done, but they are not finished yet. There is a way to do it. There is a JDBC to ODBC bridge that you can use, and then use the ODBC driver, which supports it. But if you're a Java developer, you really don't like the JDBC ODBC bridge thing. For .NET, there is NPGSQL, which also currently does not support this. It is also a work in progress. And there is also a bridge available to the ODBC driver, which they also don't really like to use. So pretty much the same state for those two. The things that have changed here is that in 8.3, we now support GSS API for doing this integrated authentication, which suddenly makes it possible for JDBC and NPGSQL to actually support this. Previously, it simply could not be done. It's just a small matter of programming. So the first thing, if you're running your Postgres server on Windows and your clients are running on Windows, there's really nothing you need to do. You need to put a line that's somewhat like this into your pghpa.conf. You might want to restrict it a little bit more than this, but this basically says anyone connecting to any database from any user from any machine in the entire world, log in with SSPI. That is the Security Services Provider Interface or something like that. That's basically the Windows interface. It will be configured by your Active Directory policies. It will use the same way to log in as if you were mapping a file or into a SQL server running on the machine. So there are a lot of policies in the Active Directory that you can set to for what you want here. If you're running Windows 2000 in your domain, you absolutely should set the policy that says no LM authentication, because that's the one that takes like less than half a second to break. You don't want that. You want NTLM or you want Kerberos, and it will automatically do whatever your Active Directory is set up to do on that. This support is always included in Windows. You can't even turn it off at the compile level. It has no external dependencies. It's as long as you're on Windows, it works. It does require a Windows NT-based platform, but that's always supported anyway, both for client and server today. And really, if you're not running a Windows NT-based platform on your client, you have bigger problems with this.
Does SSPI require A3?
SSPI requires A3, yes.
Okay.
Yes. And the fact is that prior to A3, you could not do this with Windows on the server side. We could actually do integrated authentication with Unix on the server side and Windows on the client, but not with Windows on the server. With A3, with SSPI, we can do this. Okay, so Windows to Unix is a bit more work, but this is really where we're seeing most deployments done, because if you're really going to get better performance and better manageability out of your Postgres database on Unix than Windows. And if you're in a network that's big enough that you need this, you probably have the guys somewhere around there that can run this on Unix. This will only work with Kerberos. It doesn't work with NTLM, whatever. That can be considered a feature and not a problem. Kerberos is the open standard for doing this, and Windows interoperates with Unix on it. A very quick overview of Kerberos. How many people know how Kerberos works? At least a little bit. Okay, that's about half of the 4 people. Anyway, so Kerberos, it's the cross-platform and standard-based secure distributed authentication. That's like the market speak for what it is. Basically, it's integrated login regardless of what platform you're running. It's based on the concept of shared secrets between the hosts. It does not use PKI. So in Windows, that would be the server accounts, or the computer accounts in Active Directory that have passwords deal with the shared secret. There is work to work with Kerberos with PKI, but it's not really production at this time. All these shared secrets are maintained and controlled by something called a KDC, which is a key distribution center. And in a Windows domain, that will be your Active Directory servers. It's based on the fact that the client will, from the KDC, obtain a trusted ticket. And it will then present this ticket to a server and be granted access. And it does give you the single sign-on, not just single password, not just you have the same password for every system, but actually, in fact, you log in once and you're logged in until you log off for all systems that support Kerberos in your realm. So basically, how this works, if we have a KDC, which can be 1 machine or 100 machines, we have a server and we have our beautiful client there. So when you do log into your machine, the first thing is you log into Windows, if you're logging into your Linux desktop or whatever. By default, you send a login request to the KDC, and you will get back something called a ticket granting ticket. And at this point, you are logged in, and you will never log in again. Well, there is an expiry on the ticket, so if you wait too long without doing anything, you're going to get automatically logged out. But I think in Windows, the default is a week. And if you manage to get a Windows domain client to shut up for a week and not actually do anything on the network, that's impressive. And now when you actually want to access any data, the client's going to connect to the server and send an access request. The server's going to respond back and say, I'm a Kerberos service, please show me a ticket that you're actually who you claim to be. The client is going to go back up to the KDC. It's going to send its ticket granting ticket, proving who it is, to the KDC. The KDC will send back a ticket for the service in question. In our case, it will send back the ticket for the service Postgres. This ticket is then sent onto the server, at which point the server will know who you are and it will grant access to whatever resources you should have permission to. Now, if you connect again to the same service on the same machine within a reasonable amount of time, which I think on Windows by default is 4 or 6 hours, we skip that step. Because the client will have cached both the ticket granting ticket and the service ticket. So it's basically just going to send down the service ticket directly to the server and be granted access right away. With no extra load, you don't need to access your domain controllers, and again, most importantly, you don't need to actually log in again. So So how do we do this then to make it actually work? Well, first of all, it's cover us only, and it does require what is known as a service principal. In our case, that would be a specific user account in Active Directory. Active Directory also enforces something that is not standard. The standard way to specify a service ticket in Kerberos is, actually you can do it anyway, but the recommended way of doing it is lowercase. Active Directory will only work if it's uppercase. So you will need to use the non-standard name for the service principal, which is Postgres in uppercase. Well, you can use whatever you want, but we recommend you use Postgres. So to get this working, the absolutely first thing you do is you get Kerberos working on your Unix server. Today, this is relatively simple. I set up a lab on Ubuntu just to do some screenshots of this presentation. I think it took me 2 minutes to get Kerberos working. It used to be a lot of work, and they've really fixed that up in all the Linux distros. If you're running FreeBSD or Solaris, I don't know if it might be trickier, or if they've also sort of adapted to the fact that lots of people use Active Directory. This is the only configuration I had to put into mine. I set that by default realm, which is the Kerberos name for the domain, to my domain, and basically I'm just mapping DNS names. Anything in my domain.com domain will map to realm domain.com. There is a lot of things that you can do about this. You can set strange configurations if you have very complex sets. If you have domain trust, you'll need to put that in here. But in a simple domain, this is all you need. Okay, the first thing you do at this point is that you verify that Kerberos works. You do this by running something called kinit, which, if you don't have the Kerberos login integrated into your desktop, kinit will perform the Kerberos login. And the Kerberos principal matches what is known as the SPN in Active Directory, which is basically user ID at domain. So you do kinit administrator at domain.com. It'll ask you for your password. As you can see in the screenshot, it's reasonably large. And if it, as your typical Unix command, if it doesn't give you an error, it's succeed. And then you can run the command klist, which will list your ticket cache. In Unix, it usually is in a file. As you can see, it has the default principal administrator, in this case, my log domain. And you can see we have a ticket that's called KRB-TGT, which is the Kerberos ticket granting ticket. And it has a validity of 10 hours. And it's also said you can renew this ticket for another 10 hours, for 12 hours, or whatever that's going to be. And it will, in that case, automatically renew this ticket as required. This is the output on a Linux server. It would look similar. This is with MIT Kerberos. I think it looks pretty much the same with Heimdall Kerberos. Okay, so to install this on the server, then you will install whatever required build packages. If you're running this, I think all the RPMs and the devs, they all have GSS API and Kerberos support built by default these days. If you're building from source, you need to get the MIT or Heimdall Kerberos libraries in the development version, and you will need the configure switch that is with GSS API. There is an old switch that is with KRB5, which is what we used prior to 8.3. It is not deprecated. You really should be using GSS API because it's more stable and it's easier to get working with different clients. After this, you just build and install your system as you would normally, and you will run initdb as you would normally. Well, obviously, since it's all as you would normally, if you're installing from RPM or if you're installing from Debian packages or whatever, you don't really need to do anything. It's going to do this for you. At this point, you need to prepare the Active Directory. You will create a specific user for each server that will be running Postgres. If you're running 2 database servers on the same machine, in theory, you could share the account, but don't do that. Use separate accounts for them. It will make your life easier. You create a standard user. In my case, I've called them BAD83 because it's with Postgres 8.3. It could be Postgres. It would normally be something like that, but Postgres might not work if you have only one server. Down here, you can see, check in the box, user can change password and password never expires. If your service principal password expires, you will basically have to create a new service principal because you can't change the password afterwards. And again, at the very bottom there, the enter account expired should not be on. You don't want your servers to expire. That's a bad thing. Other than that, this is an ordinary user. It should absolutely not be a domain administrator or anything like that, just a regular user. Needs no further permissions. And then we run the magic command that is actually fairly simple to find these times. It's in the Windows 2003 support tools. In Windows 2000, it's in the resource kit. And it's good to know that if you get this tool from Windows 2003 and run it against the Windows 2000 Active Directory, it will not work. It will look like it's working, but it's not going to work. It won't tell you it's wrong. Same thing the other way. If you get the tool from Windows 2000, run it against Windows 2003, it looks like it's working, but it's not working. So make sure you get the proper version, which would probably be 2003 these days. So you shouldn't be running on Windows 2000. The command we want to use here to create this principal mapping, as it's called, is ktpass. It's fairly simple. You do ktpass and then you do prints for principal. Here we got the uppercase Postgres, which is our service principal name. This is how we build the Kerberos principal in our Active Directory. If you choose something else than Postgres, fine. Make sure you do it at every place. It's slash, and then it's your fully qualified domain name. Kerberos will only work with fully qualified domain names. And then it's at your domain, again, in uppercase. That is your Windows domain in uppercase. The first one is your DNS domain. And the flag for crypto des CDC MD5 is not needed if you have a modern version of MIT Kerberos or Heimdall Kerberos. But that changed fairly recently. Before that, the default encryption used on Windows was not supported in the Unix packages. They've since changed that, but you can add that one just to be safe. Dash map user, lab83. This points to the user that we just created in the Active Directory, and this is the Windows username for it. Dash pass, foobar991 is the password for said user. And sometimes you have account policies, so you can't use foobar as a password, which is a good thing. Normally you would be using a really good password for this because you can never change it. So, I mean, randomize a 63-character long password and just, you're going to use this in two places and then you're going to throw it away. And dash out postgres.ktag, which is the file that we will put up this file with the encryption keys. Get a bunch of output, and if you don't get an error anywhere, you see let's see, line 1, 2, 3 says key created. That's the success. You need to verify that this account has been properly mapped. If you open this account that we just created again, you can see that the user logon name is no longer lab83. It's actually postgres/lab83. Your domain. Whereas the user logon name pre-Windows 2000 is still what it used to be. And this is the actual Kerberos service principal name that has been generated. You need to copy this file to your Unix server. Normally you stick it in the data directory, so it will be included in your backups. You can put it in the system-wide if you have many Kerberos services on it, put it in the system-wide file. But the important thing here is you got the command line curve server key file. Point to wherever you put this file. The Postgres user should have read access, no need for write access. It's only going to read the thing. The first there, listen address is equals star. Kerberos only works over TCP/IP. It does not work over Unix sockets, ever. It could be a way to sort of trick TSS/IP to it, but the whole thing is it's based on mapping the fully qualified domain name server to a service principal. There is no fully qualified domain name on a Unix domain socket. And the curve serve name set to Postgres in uppercase because Postgres will by default be built with it in lowercase. You can change that by a configure command line, but it's better to do it in this file. Then you can switch between different packages and whatever, and it will work. And the pghpa.conf line is the same as the one on Windows, except GSS instead of SSPI. That will activate the open standard GSS API interface. Now, Windows clients can still use SSPI to talk to a server running GSS API. It just doesn't work the other way around. So on the client, you will need to somehow set the principal name. The easiest way to do this is to set the environment variable pgkrdsrv name. The only hard part is to remember how to spell that name. You can also set it as a parameter in the connection string. That can be a problem if you're using any of the tools that give you a nice little dialog box where you type in server name and username, because there is usually no box available for this. You will need set this on Unix and Windows, really. No difference. On Windows, you set this in the environment variables checkbox, or sorry, dialog box. Everybody tends to put it up there in the user variables on the top. That means it will only work for one user on this machine. Put it in one on the bottom, and it will work for anybody who logs in, because those are the system-wide settings. And you can see, well, PG Kirby surname is Postgres uppercase again. That's really it for making integrated authentication work. It is that simple. When I started doing this for Postgres 8.0 and 8.1, it was a whole lot more complex. Most of the advances really haven't been in Postgres. They have been in the Kerberos packages on the most common Linux distributions. They now work out of the box with Active Directory. So if you're on an old version of Red Hat or whatever and want to do this and run into problems, look at upgrading. It will make your life a lot easier. There are other good reasons to upgrade as well, but that would be one. Now there are cases when you have these clients that don't support GSS or SSPI, such as the current JDBC if you really don't want to use the ODBC bridge. Or there are actually cases when you want passwords. For some reason, some users like the illusion of security of having two different passwords. We can have hours of debate whether that's actually more or less secure, but some people want passwords. And they still want to use the same password. They want to use their Active Directory account. And we can do this using LDAP communication, because Active Directory is just another LDAP directory. To the client, this looks just as if your server was configured to do standard password or MD5 authentication. There is no way for the client to know where you're checking the password against. And it's simply an added row to your pghpa.conf. It's a bit more complex, but we'll start with the same. All databases, all the word, LDAP, and there is a specific URL. That is basically, you need to point to a domain controller. You can point it to one of the round-robin DNS entries that point to all your domain controllers, but it has to point to the domain controller. You put in the, DC equals domain DC equals com, which is the root of your Active Directory, or the point wherever your users are going to be. Then after the semicolon, we have domain backslash, and this is, the Postgres LDAP parameter will take first a prefix and then a suffix. And it will do if the prefix exists, it has the prefix, then the username, and then the suffix. To log into the easiest way to get into your Active Directory is to use domain backslash, to enter the sort of NT style way of doing this. You can use the CN equals style, that is the LDAP style, but if you do that, all your users must live in the same OU, because it has to sort of bind it in as a distinguished name. But if you use the domain backslash syntax, it will pick up the user wherever you happen to be in the Active Directory. And it'll verify the password. You can, instead of LDAP, you can use LDAP-S if you want. Then Postgres will use SSL between Postgres and the domain controller. Otherwise, the password travels in clear text here. If you do that and use it on Windows, if the server is Windows using WinLDAP, that'll work fine. If it's a Unix server using OpenLDAP, you will need to look into the OpenLDAP documentation, figure out where to put your root certificate, because OpenLDAP will not do this unless it trusts the server certificate of your domain controller. There is a way to do that. It's not very easy to find the documentation of OpenLDAP, but it's there. But if your machines are standing next to each other on a secure network in the data center, you might not need to bother encrypting that. Or you can use IPsec or whatever to encrypt the network all the way. Now, once you've been able to authenticate against Active Directory, you might actually want to use your data there. That is one thing that is very nice in SQL Server, is that you can run queries against your Active Directory. You can do this in Postgres using DB-link LDAP, which is on PG Foundry. It is not as convenient as some of the stuff that you can do in SQL Server, because this is a more generic solution, and SQL Server has an Active Directory specific solution. But it can do a lot of things. The current version is available as built from source only, because there aren't that many people using it. And what you'll basically do is you will create views that will point into your LDAP directory. You can have a view for all your users, a view for all your groups, a view for all your users in a specific department, or whatever. These are generic LDAP queries. DB-link LDAP is read-only, unlike, I think, the Microsoft provider, where you can actually update your users through PostgreSQL. We can't do that. We can only read the Active Directory. Here's a beautiful example of a view that will get you every user in your directory. It's the create view user as select star from DB-link LDAP. We're going to put in again the name of one of our domain controllers or a round robin name. Actually, no, this one does not support round robin names. OpenLDAP does not support round robin names. WinLDAP does. So if your server is Windows, you can use a round robin. If it's OpenLDAP, you will need to specify a particular domain controller. You put in the base VM. On your default domain, that would be cn equals users. That's where all your users are going to be. And dc equals domain, dc equals com. We put in whatever user we're going to connect with. This one needs a specific user to connect to. It can't sort of pass through the client's login. It needs a specific user. You can just, if you're going to use it in production, you create a user specifically for this purpose. Put it here. You got the domain /user. With a little e there for the string escaping. You put in the password for this user. The next field is any kind of LDAP filter that you can think of that Active Directory will support. Just doing object class equals user would be the simplest one you can find, but you can map on any field that Active Directory has. It will use the Active Directory indexes if it's indexed, or it will just do a sequential scan otherwise. And then you list whichever parameters you want to get back. In this case, we get back the distinguished name, the CN, and the display name. The name of all these attributes that are available in your Active Directory is on MSDN. You can always figure it out by looking at the GUI what the actual attribute name is. But MSDN has the reference for all this. And you can get back pretty much anything that's in there. And then there is the Postgres syntax for doing the DMC and displaying it, like how do you want it to look when it comes back out as SQL data. And if we select from this one, simple example, which is probably too small for everyone to see, but you get it back, you get the distinguished name, the CN and the display name for the two users that live in this domain. But it's irregular. You can join this to whatever you want. I've been using this myself as a user management system. We have tables in the database that says which users should be existing. So we can run verification queries against it, joining, seeing which users are missing, which users have different names in the user management system and in the Active Directory. All these things. It comes back as any kind of virtual table that you will have in Postgres. So a quick look at monitoring. I think we're still good on time. We don't really do monitoring on Windows really very well, which is another reason why that Linux server running your database in your Active Directory is a pretty good idea. But if you are running your servers in Windows, we have performance monitoring from Windows, and you will monitor all the regular parameters, exactly the same ones you monitor with Oracle, or with SQL Server, or with DB2 or whatever. Your memory parameters, your disk queue logs, all these things. We don't have any specific performance monitors for Postgres. We have PGS and MPD. If you're running it on Unix, we don't have this on Windows. But we do have all the PG stat views are exactly the same on Windows as they are on Unix. There is no difference, but you will have to sort of write your own little script to all of them and see what happens. We don't interface with Performance Monitor. We don't interface directly with anything like Operations Manager or any of those things. It is something we would like to do, but we don't. We don't have WMI support, except, again, accessing these default settings. Also some stuff we'd like to do. So monitoring is actually a really weak spot on that part. Actually, what you can do, the performance monitor is very good for monitoring it from the operating system side, and you can use process groups and job objects to monitor all these things. If you're interested in more details about those, you can look on my website. I gave a talk at PGCon last year that listed good things to look at on your operating system, performance monitor when running Postgres on Windows. So you want to take a look at that. Future directions that we'd like to work with for making this work better in a Windows environment. I'm unfortunately not going to say that I will have the time to do this, but I would like to have the time to do this. I'd like to do S-channel encryption and S-channel certificate authentication, which would mean that you could use the Windows certificate services to do cross-domain authentication and cross-internet authentication when you don't actually have access to your domain controller. I would, as part of the second point here with S-channel certificate authentication, I would like to do any kind of certificate authentication with Postgres first, and then specifically support as channel. Obviously, it should work just as fine with OpenSSL certificates or GNU-TLS certificates, but Windows specifically, if you have as channel, you can work with certificate services, and it makes your life really, really easy. And as I said, we really would like to have some better monitoring support. And we'd like to have the SNMP support on Windows as well. And it would be good to have a native performance monitor plugin, like the big commercial guys do on Windows. Does anyone know if MySQL has one? They do?
Oh, if they actually have one?
No?
I'm not sure.
No. Would be interesting. No, all the big commercial ones do. Obviously, you just sort of pick your category of counters and look at SQL Server or whatever. We'd like to have that. Not sure if it's probably not going to be something that lives in Postgres. It's going to be a PG Foundry project that it might get wrapped up in the store, it might be in Stack Builder. It should be available in some way to monitor more than one machine in like your environment. If you have a native performance monitor plugin, it will automatically be accessible through Operation Manager and all these domain-wide management tools that are available out there. That's about all I have. Any further questions?
What was the name of the connection string that should you specify regards to domain or server?
Let's
Write
see.
that down what I just said.
Yeah. Somewhere. That would be the one. The PG KRB SRV name, if it's an environment variable, or just KRB SRV name,
KRB is right.
if it's a connection string parameter. And again, that one works for both Kerberos and GSS API. SSPI doesn't care. So you can run, if you have older clients, you can run them with Kerberos mode, but I really suggest you go to GSS API. It is much better. There are some client-side crashes in the Kerberos code from MIT, unfortunately, which they have been unable to find. But it happens now and then that the client just, it doesn't even give you an exit code because, oh, it's gone. And they don't really know where that comes from. I should add that there is another interesting, if you have a very advanced domain configuration whereby you want to independent Kerberos settings, one that's independent of your Active Directory, there is another connection parameter that I don't remember what it's called that can switch you, because by default the Windows client will use the Windows SSPI interface even when connecting to a Unix GSS API server, because they are wire level compatible. But if you specifically want to use the MIT Kerberos library on Windows, you will need to add another parameter to your command line. That I don't remember what it's called, but it's in the documentation. Normally, if you're again, the Windows Enterprise where Active Directory rules your world, you don't need it. You will be happy to know that it will be using your Active Directory line.
Just to be clear, every user in your active domain that you want to access your Postgres site the user has to be in Postgres also?
Yes. Yes. I was about to say there were tools out there, but there aren't because I've probably released them before I quit the job where I made them. But basically, you can pretty simply use the dblink LDAP and the cron job to automatically add the users. Or in my case, I pulled down a group from I had an Active Directory group that listed all the users that should have permissions, and I have a cron job that automatically synchronize that with users in Postgres. It's pretty simple to do, like a 25-line cron script. Okay. Thank you very much for coming to this very popular talk.
Thank you.